Everyone right now is arguing about whether AI is going to replace their desk job or write their emails. But while we are distracted by chatbots, the CEO of the most powerful company in the world is playing a completely different game. In a brand new interview, NVIDIA's Jensen Huang casually laid out the actual endgame of artificial intelligence, cracking the code to human biology and literally ending human disease. And the craziest part? He says we are less than 5 years away. To understand how a computer chip company plans to cure cancer, you have to realize that AI is no longer just reading the internet. It is learning the laws of physics. The goal is to simulate realities built on the laws of physics or chemistry and biology. Right now, your favorite chatbot is only a text generator. But these simulated realities are way different. They're built on fundamental laws of physics or chemistry, and they can simulate thousands of scenarios in seconds, while making those scenarios in a lab would take several years just to map the desired protein and apply a fix to it. AI simulated realities would do that for use in seconds. Now, first, let's show you a segment on how NVIDIA is planning to expand into many more industries, such as medicine. And the juicy part in Jensen Huang's timeline you will see towards the end. I have also simplified what he says so you would be able to understand how this would play out. Here we go.
On the one hand, we want world-class models as products, and they should be proprietary. On the other hand, we also want AI to diffuse into every industry and every country, every researcher, every student. And if everything's proprietary, it's hard to do research and it's hard to innovate on top of, around, with. And so open source is fundamentally necessary for many industries to join the AI revolution. NVIDIA has the scale and we have the motives to not only skills, scale, and motivation to build and continue to build these AI models for as long as we shall live. And so therefore we ought to do that. We can open up, we can activate every industry, every researcher, every country to be able to join the AI revolution. There's the third reason, which is to recognizing that AI is not just language. These AIs will likely use tools and models and subagents that were trained on other modalities of information. Maybe it's biology or chemistry or, laws of physics or, fluids and thermodynamics. And not all of it is in language structure. Mm-hmm. And so somebody has to go make sure that weather prediction, biology, AI for biology, physical AI, all of that stuff can be pushed to the limits and pushed to the frontier. We don't discover drugs, but I want to make sure that Lilly has the world's best biology AI systems so that they can go use it for discovering drugs. And so these three fundamental reasons, both in recognizing that AI is not just language, that AI is really broad, that we want to engage everybody into the world of AI, and then also co-design of AI.
Let's stop saying AI is just really smart and look at the actual physical mechanics of how a supercomputer cures a disease. To understand this, you have to realize that your DNA is just a recipe book. The actual physical machines doing the work in your body are proteins. Think of a protein as a long string of molecular Lego blocks that folds up into a very specific 3D shape. If your DNA has a typo, a mutation, it builds that protein with the wrong shape. Why does that make you sick? Because in biology, shape is everything. For example, if the protein that acts as the off switch for cell division is folded wrong, the switch gets stuck in the on position. The cell never stops dividing. That is exactly what cancer is. So, to stop the cancer, scientists need to design a drug, a 3D molecular key to perfectly fit into that broken protein and jam the gears. But to build the key, you first have to see the exact 3D shape of the lock. For the last 50 years, doing that was a nightmare. You might be thinking, why did it take so long? Just take an X-ray. But this isn't like X-raying a broken bone. To photograph a microscopic protein, scientists first had to force it to freeze into a flawless physical crystal. Proteins hate crystallizing. It took scientists years, sometimes decades, of blind physical trial and error just to coax a single protein into a crystal before they could even take the picture. Here is the massive shift Jensen is talking about. AI skips the physical lab completely. It just reads the DNA recipe, calculates the thermodynamic forces between the atoms, and predicts the exact 3D shape it will fold into. What used to take 5 years of trying to grow a crystal now takes an AI a few seconds. And once the AI maps the 3D lock, the drug discovery begins. Before AI, Big Pharma had physical warehouses full of millions of chemicals. They had to physically drip them into petri dishes one by one, crossing their fingers that one of them accidentally fit the cancer lock. It was incredibly slow, physical trial and error. Now, the AI does it digitally. Yes, it is still doing trial and error, but it's doing it inside a supercomputer at lightning speed. It takes millions of digital molecules and simulates throwing them at the digital lock, calculating the exact gravitational and chemical pull between the atoms to see what sticks. But it gets even crazier. Instead of just testing existing chemicals, scientists can use generative AI. Just like you can prompt an AI to generate a brand new picture, they prompted the AI to invent an entirely new, never-before-seen molecule from scratch that is mathematically optimized to fit the lock. They are essentially writing the code for a drug before a single test tube is ever touched. Jensen isn't manufacturing the pills. They are building the massive computational physics engines that let pharmaceutical companies simulate millions of these key and lock scenarios in the time it used to take to physically test just one. You no longer guess the cure, you compute it.
When you think about the future quite a bit, when you look out 10, 20, 50, 100 years from now, what gives you hope?
I think the things that give me incredible hope is what I see as I extrapolate, what I see now is possible, and as I extrapolate based on the things that we're doing, what will very likely happen,
Mhm.
and and that there's so many things that we want to solve. There's so many problems we want to solve. There's so many things that we want to build. There's so many good things that we want to do that are now within our reach and within the reach of my lifetime. You just can't possibly not be romantic about that. You know what I'm saying?
Yeah, what an
You just,
exciting time to be alive.
yeah.
Like
How can
truly so.
how can you not be romantic about that? The fact that there is it's a reasonable thing to expect the end of disease. It's a reasonable thing to expect. The first job that computer scientists said, AI researchers said was going to go away was radiology, because computer vision was going to achieve superhuman levels, and it did. Computer vision was superhuman in 2019, maybe a little bit later, 2020.
Mhm.
Okay, and so it's been a long time since computer vision has been superhuman, and so the prediction was radiologists would go away, because studying radiology scans was a thing of the past. AI will do that. Well, they were absolutely right. Computer vision is completely superhuman. Every radiology platform and package today is driven by AI. And yet, the number of radiologists grew.